Okay then guys, nice and quickly, I'm going to just go through multiplying by a single digit for you to see that clearly. Let me sit down so my shadow doesn't come in the way. Right, so we're going to look at this sum here. 673 multiplied by 6. That's our target. And this is what you would have done back in the day. We would have done this of 673 multiplied by 6 written here. Does that fit on the screen okay? Excellent. What we would have done then is we would have done a one line job, and we've done 6 times 3, which is 18, 8, and we would have carried the 1, so the 1 would have been carried under here like this. We would have done 6 times 7 is 42, plus the 1 is 43. Keep the 3, carry the 4 like so. We then would have done 6 times 7, which is, 6 times 6, which is 36, plus the 4, which is 40. So we've gone 4, and we'd have gone there like that. And that would have been the answer. Nice and quick and nice and easy. The only problem is here is lots of maths has been done and numbers been plonked somewhere with no true explanation, and that's what causes an issue in other things we learn. So in schools now, they're kind of looking at not only making the method be one that gets to the correct answer, but if we get it wrong, we can see what we don't understand about our own number system. So rather than starting from the units, some schools will start from the hundreds instead to have enough columns in place. 6 times 6 is 36, as we know, but this isn't 6, it is 600. It's 100 times bigger than that calculation I've just worked out. So there's my 36 with 2 zeros, and I put my zeros in the right column, 0, 0, 6 and 3. So not only am I practicing multiplying big numbers, but I'm also practicing placing things in the right column as well. Again, it helps with my adding and all that stuff. 6 times 7 is 42, but I've not got 7, I've got 70. So it's 6 times 70, which is 420. 420. And then 6 times 3 is 18. And what I do then is I add up these. 8, 3, 0, carry the 1, and 3 and 1 is 4. So my answer is still 4038, but within that, where I've gone wrong, I should be able to see what I do or don't understand. Next video is multiplying by a double digit. Hopefully that was okay for you guys. Hey, B-Dog's Maths here, and I'm B-Dog, and I'm your saviour, because we're going to start in our primary parent video number 1, which is all about multiplication. Okay, so we're going to look at multiplying by 1 digit, then by 2 digits, and then by decimals. Those are my 3 things I'm going to look at. There is a method out there, or a skill out there, called the Chinese method. I'm not going to do that in this video, but if you do want to see that, comment below, and I'll do another video just showing you how that skill there. It's a nice one, but I want to stick to the scheme of work really for primary school, so you can see a generic thing. But if anything comes up that you want to see, just comment, and I'll get that done. Okay. I'm here for you guys. The more you comment, the more you talk about it, the more you're going to make this resource really personal for yourself. So please don't be shy. Loads of parents are saying it. All these parents are saying the same thing. I need help with this. I need help with that. What on earth is this? What on earth is that? So please just talk to me and we'll work together. Okay? Best of luck. Here we go with multiplying by single digit. So here we are again now. Multiplying by 2 digits. Let's make up a sum. Let's go with 584 multiplied by my lucky number 23. Okay. Now again, the way we would have done it back in our day, I try to think of myself as quite young, but unfortunately that's not the case anymore. Times by 23. Again, we put one line down, and then we do 3 times 4, which is 12, and we keep the 2 and carry the 1. Now, this is what always confused me. Where do we put this 1? So I'm going to put the 1 underneath this bit here. 3 times 8 is 24, plus the 1 is 25. So the 5 goes there, and the 2 gets carried. And 3 times 5 is 15, and then 15 add the 2 is 17. So I'll have the 7 and then move the 1 here. So I did 3 times 4 is 12, 3 times 8 is 24 with the 1, 25, 3 times 5 is 15 with the 2, 17. So I've done 3 times everything, and that's what you would have done at school. The next stage, we would then just put a random 0 in here, known as a placeholder, And then we just do 2 times 4, which is 8. 2 times 8, which is 16. 2 times 5, which is 10, with the 1 is 11, and we'd have that there. We would then add the whole lot together, so we'd end up with 2, and we'd end up with 8 plus 5 is 13. Can you see all that on there? I'm just going to move this over a little bit. There we go. 5 add 8 is 13, so carry the 1, and then 7 add 6 add 1, which is 14, carry the 1, and then 1 add 1 add 1 is 3, and then that would be 1. So that would be 13,432 is your answer. Okay, and you would be asked to just do loads and loads of them until you're getting it right. And again, if you go wrong, it's very difficult to see where you've gone wrong and what concept within that you're missing out. Some people forget to put the placeholder because they don't realise that this will actually be 584 times by 2 and then times by 10. So what we're doing is multiplying by 10 first by moving every digit to the left one. So as you can see, it can be, for somebody that doesn't practice this 50 to 60 times like we used to, this can be quite confusing. As confusing, if not more confusing, than the other methods that we use. Okay, so here's one method that we do at a primary school, known as the grid method. We would write down, and again this has slight variations, but the concept is the same. We would split up our, it's quite neat for me, split up our box up into a 3 by 2 because we're doing a 3 by 2 problem. And we would have the 5, 8, 4 along the top. And we'd have the 2 and 3 down the side. We would have to remember that this is actually 500, this is 80 and that's 4, this is 20 and this is 3. So we'd have to have these, the actual value of the digits rather than just the digits on the top. Then we'd systematically fill the boxes up. So in this box here, we're doing 500 times by 20. 5 times 2 is 10. And this number is 10 times bigger than what I use. This number is 100 times bigger than what I use. So I'm going to have 1,000 times bigger overall amount. So I'm going to have 3. I'm going to move that along 3 places. So that's going to be 10,000 in that box. 80 times 20 is 8 times 2, which is 16. And then multiplied by 10, multiplied by 10, so multiplied by 100. 4 times 2 is 8, multiplied by 10 gives me 80. And then we do 500 times by 3, which is 1,500. 80 times by 3, which is 240. 4 times 3, which is 12. Okay, so it's asking for a lot of different maths to go over. Then we have the issue of having to add these 6 numbers together to get our answer. So, many ways of doing that. We can go across here first. And let me just see if this can fit on the camera. Yeah, just about, okay. So we got 10,000 add 1,600 add 80. Well, 10,000 and 1,000 is 11,680. And then this one, 1,500, 1,740, if I add these two together, 1,740, 1,752. Can you see the issue with this method? It's asking for a lot of addition to go on, a lot of addition in our head to carry on as well, looking at these things. So you might want to spend some time, if you find this is an error, this is a confusion problem for the student, or your child, is to generate a few of these sums and get them to do it in their head. This is where the practice comes in, you see. So practicing doing this is far more beneficial than it is practicing to do this, because that's going to include more skills that you're most likely going to need in real life, adding lots of numbers together in your head rather than remembering where digits disappear to. So that's why we prefer this method here. And then we can add those two together. 0 and 2 is 2, 8 and 5 is 13, so we carry the 1, 6 and the 7 and the 1 is 4, so 6 is 14, yes, and then 1 add 1 add 1 is 3, and then the other one makes it 1 there, so it still gives me 13,432. But within that, I am practicing so many different skills that's going to make me a better mathematician, whereas here I'm practicing like where to put digits somewhere, and I'm not really dealing with the values of the digits that I'm working with. So this is why this method is preferred nowadays, because rather than just having robots, we want thinking individuals to help with their future maths as the world is changing so rapidly. Okay, that's multiplying by 2 digits. I'll come back to you with a quick chat about multiplying by decimals, and then we're going to go from there. Alright. How you doing so far then? Hopefully this is not going too fast, or I'm boring you at all, but we're getting there now. So I want to finish off this video again looking at multiplying by decimals this time instead. Okay, let me just see if that fits on. Yep, just about. And I want to just really, there's many ways of doing this, but I like to see more of the investigative, the compensation, the reasoning style of looking at this, because that's going to help the students in the future as well, your children in the future of their mathematical career. So let's have a look at 584 times by 23 and how that equals 13,432, which we've just worked out on the previous question. Now let's say I wasn't asked that question, but I was asked one that's very similar, 5.84 multiplied by 2.3 for example, and I wanted to know the answer to that. The first idea in my head is that I look at how the question is changed. So this number has changed because it's divided by 100. And again, if your child struggles to understand that, you have to do some work on dividing by 100. And then here is a divide by 10 job. So the 584 is now 5.84. The 23 is now 2.3. And what will that do to my answer? Well, if I'm dividing this thing by 100 and dividing this thing by 10, then that's really taking my value down by a heck of a lot. So it's taking it down by 1,000, dividing by 10, then dividing by 100. And that's going to take it down by 1,000. So my answer will still have the same digits, but I'm going to divide it by 10, 100, 1,000. So my answer is 13.432. Yes, we could have guessed that. And yes, we could have just been said, well, if you see 2 digits here and 1 digit there, then the answer's going to have 3 digits after the decimal point. I've heard that being said, but that is, again, it's another trick that people have to try to memorize amongst all sorts of tricks to memorize. We don't want that in our students. We want them to be mathematicians. So if they don't know what to do, they can see some patterns because they understand the number system. All about the method is all about understanding the number system. So let's just say, for example, my question was to ask me to work out 6.83 multiplied by 3.4. I would work out 683 multiplied by 34 using one of those using that previous method. I would get my answer and understand that if this to here is a divide by 100, this to here is a divide by 10, then this answer to my new answer will be a divide by 1,000. So as long as I get this correct, I know I'm going to get this correct. And that is multiplying by decimals. What you actually do is you ignore the decimals and then look at how you've changed the numbers afterwards. And that works for large numbers, small numbers, everything. Just treat it as whole numbers, normal integers to start off with, and then look at the reasoning behind how your question varies. Okay, excellent.